Assume alpha increases monotonically and alpha dash belongs to Riemann integral on closed interval AB. And let f be a bounded real function on closed interval AB. Then f is Riemann integral if and only if f alpha dash is Riemann integral. So in that case, integral f of d alpha is equal to integral f of x alpha dash x dx. Very, very important result. So I'm going to start with, it's given to us that alpha dash is Riemann integral, right? So from here I will get my partition for alpha dash, right? And then after that we will go further. Now proof, let epsilon be positive given to us, and since alpha dash is Riemann integral, right? So there exists a partition P equal to, this is a sign for there exist, a partition P equal to x0, x1, x2, xn of closed interval AB such that UP alpha dash minus LP alpha dash, this is less than epsilon. Fine, and let me mark this as 1. And now let me apply the Lagrange's mean value theorem over here. By Lagrange's mean value theorem, there exists Ti belonging to this interval xi minus 1 xi such that, what is the Lagrange's mean value theorem? This alpha dash Ti is equal to, yes, alpha xi, very good, minus alpha xi minus 1 over xi minus 1. Fine. So this is equal to delta alpha I, right? And this is delta xi, right? So from here I get the value of delta alpha I, which is equal to alpha dash Ti delta xi. This value of delta alpha I will going to use. This is for all I equal to 1, 2, 3, yes, 4, so on, up to n. Now put m equal to supremum of fx over closed interval AB. Let me this m to be the supremum of fx, right? Now since, let me take this mode. Why I'm going to take this mode? Because I need this in my result. So consider this mode, summation I going from 1 to n f of si delta alpha I minus summation I going from 1 to n f of si delta dash si delta xi, right? This is equal to, I just take this summation first. This is f of si, yes. Just now I have calculated delta alpha I to be equal to alpha dash Ti into delta xi, right? This is minus summation I going from 1 to n. This is f of si. This is alpha dash si. And then this is delta xi. Up to here it's fine. Okay. So this is equal to, now next what? Let me take this f of si common with summation. So I have taken summation f of si common. So what I get alpha dash Ti minus alpha dash si delta xi. So this is equal to, because I know that maximum value is m, right, for f on closed interval AB. So can I write this as less than equal to capital M for this f of si? Yes, I can write. So this summation is going from 1 to n on this mode alpha dash Ti minus alpha dash si, this delta xi. This is m is the supremum of fx, right? So this is further less than equal to m. Now this sum, this is what? This is actually UPF alpha dash minus LP alpha dash, right? By C. LP alpha dash is less than equal to summation this SPF alpha, which is your Riemann sum, right? Okay. So, and if I write summation alpha dash si delta xi, so So this is less than equal to UP alpha dash. That is LPF alpha. Here I am having alpha dash, right? For alpha dash, I must write LP alpha dash. Just remember this, right? Okay. LP alpha dash is less than equal to Riemann sum. That is alpha dash Ti delta Xi. Okay. Now this summation alpha dash Si delta Xi is less than equal to UPF alpha dash. Alright. Now if I take the difference of these two, the mode, this will be less than equal to difference of the nth. Yes. And this is further less than equal to epsilon. Very fine. That means this mode alpha dash Ti minus alpha dash Si delta Xi is actually less than epsilon with some. Yes. So I'm writing this as this alpha dash Ti minus alpha dash Si mod delta Xi is less than equal to UP alpha dash minus LP alpha dash, for which at the very start I have mentioned, because alpha dash is Riemann integral, from here UP alpha dash minus LP alpha dash is less than epsilon. So here it is further strictly less than m epsilon, which can be taken as epsilon dash. Fine? Okay. So therefore, this whole mod is less than epsilon dash. I'm just going to mark this as fine. I will use this too. Alright. So this implies this mod is less than epsilon dash, which implies what? If, let me write with black color. See, this is your complete mode, alright? This is your complete mode. Now, if mod x is less than epsilon, what does this mean? That x will lie between minus epsilon and plus epsilon, which implies x is less than epsilon. This I am going to do this here. Now this complete mode is less than epsilon dash. So can I write from here that this summation I going from 1 to n f of Si delta alpha I is less than summation I going from 1 to n f of Si alpha dash Si delta Xi plus epsilon dash. Can I write like this? Alright. So this is now less than equal to, I know that this is my Riemann sum actually, which is SPF, not SPF alpha. Whenever I'm having alpha dash, so I'm going to use this as Riemann sum as SP alpha dash. SPF. Okay. So this is less than equal to UPF alpha dash. This thing. And this is your delta. Function is what? Function is FSI alpha dash SI. So here UPF alpha dash. Very carefully notice this. Plus epsilon dash. For all choices of SI belonging to this Xi minus 1 Xi. Please take this step as a reminder or commit to your memory. This is FSI alpha dash SI. For this, I should use UPF alpha dash, F alpha dash, right? Plus epsilon dash. Please take care of this. Alright. Now I am going to take the supremum over all the partitions of closed interval AB we get. Okay. Taking the supremum over here, what we get? Yes. Supremum of this is UPF alpha, F alpha. So UPF alpha. This is less than, this will be UPF alpha dash, right? And then plus epsilon. UPF alpha minus, taking this to the other side, UPF alpha dash is less than epsilon dash. Okay, let me mark this as star. Now the same argument from again to that, what is my 2? This is This complete mode is, if this complete mode is less than epsilon dash, then let me interchange the positions, because I know that mod of, if I take mod of a minus b less than epsilon, then a minus b is less than epsilon. Also, b minus a mod less than epsilon means b minus a is also less than epsilon. Please understand this. If mod of a minus b less than epsilon implies a minus b is strictly less than epsilon, then if I interchange mod of b minus a less than epsilon, this also means that b minus a less than epsilon, isn't it? Yes. So what is my 2? I have taken just as it is this mode to be less than epsilon dash and get my result, this star. Now what I am going to do is just interchange these two, which is less than epsilon dash, and after interchanging them, I will get the result. The same argument leads from 2 to UPF alpha dash, because it is now interchanged. So this is less than, just you have to change the sign. UPF alpha plus epsilon dash, right? So this implies UPF alpha dash minus UPF alpha is less than epsilon dash. Taking the negative sign all over, this is negative UPF alpha dash plus UPF alpha is greater than minus epsilon dash. This implies UPF alpha minus UPF alpha dash. This is less than epsilon dash and is greater than negative epsilon dash. If you look at your star, so I have used this result and this double star result. From these two, I get this result, which means again I am taking this back into the mode. So this will be mode of UPF alpha minus UPF alpha dash less than epsilon dash. Fine. Now, since what is my statement 1? This one, UP alpha dash minus LP alpha dash less than epsilon. This is true for all refinements of P. So therefore, this 3. This is also true for all refinements of P, right? So let me write the statement. Since 1 is true for all refinements of P, therefore 3 is also true for all refinements of P, right? Okay, so from 3 we conclude that mode of, now UPF alpha, can I write is as upper Riemann integral FD alpha minus, this is A to be again upper Riemann integral for, now this will be your f of x into, because here it is f alpha dash, so alpha dash also multiply with fx dx. This mode is less than epsilon dash, isn't it? Yes, but epsilon was arbitrary. Let me write, but epsilon was arbitrary, and also alpha dash is Riemann integral, f is also given to be Riemann integral, so therefore this is f d alpha is equal to A to b f of x alpha dash x dx. So therefore one thing more, that equality of lower integrals follow from 2 is exactly the same, right? If we have done for the upper Riemann integral, so the equality of lower integrals also follows from 2 in exactly the same way. when you take the infimum over all the partitions, right? So because f is Riemann integral and alpha dash is also Riemann integral, so this upper Riemann integral will be nothing but my common integral. I can write it as a common integral, which is f d alpha is equal to a to b. It is just equal, right? F of x alpha dash x dx. Upper Riemann integral is equal to common integral. F is Riemann integral given to us, so hence the result. Here ends up the proof. Thank you so much for watching this video. Please do step by step, learn step by step what steps we have done and just apply the definitions. It's very easy, right? God bless you all. Have a very nice day.